So after the previous two talks, very senior leadership within the research community, hopefully my talk is a little bit the change of the pace. As I had a very interesting life for the past 3 to 4 years. So I see myself, I'm a professor that is very enjoyed in networking, in software, and I enjoy both on the research side and the implementation side. So from starting to work with Genie, that really opened up a very interesting perception of myself. So I realized that to really solve the challenges, you have to understand from different angles the problem. And you really have to work with people in those different aspects of the community to learn from every aspect of that and come up with the solution. Within the limited time, I'll probably go through many different aspects of my life for the past several years, working on several different positions. So right now, currently I have 3 different hats that I wear. I'm a professor at Clemson University in South Carolina, working on National Science Foundation projects. So that's one role I play, leading my students, my postdocs, my research group, to implement a lot of these research prototypes, distributed test beds. My second hat is the director for a new research center called the Center for Next Generation Computing back at Clemson. That is a very new idea back in the campus. I work closely with the IT organization at campus. So we went through several different phases of working together. And I think that fits in a lot of the Federation discussion we have in this conference. So we start with understanding each other, start with simple collaborations, trying to get research experimentation working on the university. And then over the course of the years, we start to realize we can actually build the environment not just for research, but also in the production context, helping the production, helping the organization. And eventually we created this transformation back on campus to create the new infrastructures and the new organizations to work closely that is always combining 3 aspects within the university. That is the faculty researchers, the IT organization, and then the students. So we create this new research center such that we can work together and create these new solutions. And oftentimes that helps into the community discussion. For example, the Federation. For example, the network interconnects within the software-defined networking context. So the third cap I wear is actually a software engineer myself. So 2012, I started my sabbatical at Stanford University, and Stanford, everyone knows, is generating startups like crazy. So within the same period of time, for software-defined network, there's 2 startups coming from the Stanford group. And work with one of them, which is the Big Switch Networks, which has a starting vision of making a software-defined network really open to the bigger communities, and then actually working with the real physical networks. Not just the virtual, but also the physical. And that means you have to work with a lot of different sectors within the industry, within the academia, to identify all these interfaces within this hardware and software boundaries. So since 2012, I worked with them. I worked on the Floodlight project for some time, which is an open source software project. And over time, I evolved to work on OpenStack, CloudStack. Still right now, I maintain a working relationship with Big Switch. So you can also sense a little bit of engineer perspective from my presentation. So today, I want to go through this simple outline. First, sort of realizing what are some of the most important emerging trends within the world. And all of them eventually is linked to software. We are controlling all these different aspects of our life through software. And then from that, we realize that all these different needs in the world eventually anchor at very common infrastructure. You have the computing, you have the networking, you have the storage. These are all the fundamental elements that drive a wide range of applications that the world is running together. So to actually enable the technical operation of the software-defined infrastructure is actually not hard. Anyone within the computer science community can quickly put their hands on a new project. You can download the software, you can learn about the software, and you can be starting to program and control the network or the computing in one day. The question is, given that everyone can do this, everyone can start up an instance of such infrastructure, you're going to see thousands or up to millions of these different entities. They're all very similar in terms of composition. They're all sharing very similar interfaces. So now the question is, most of the things everyone wants to do is actually the interfacing with all the other thousands and millions of similar entities. So that comes to the federation. So what I see today, hopefully, I'll convey that to you at the end of the talk, is I feel that the technical pieces, the building blocks, are pretty similar to do today. And that's the benefit that we have today. And the hard questions to answer is, what do we want to do about the interfacing of these elements? And then that helps us to decide how do we shape the policy, how do we deal with federation. So finally, the last aspect of my talk will be how to go from today's experimental testbed thinking and into thinking about these are actually elements that will go into the future internet. In fact, the way that we have been building these future internet testbeds, the distributed cloud testbed, is with a mindset that they should be developed in the production context. They should be operated as a production infrastructure, of course, with limitations today, but then the logical framework and process that people deal with it never leaves the thinking of what should it be in the real world. So with that, we start to see some of these building blocks that will appear in the future internet. We start to do some experiments with NSF research projects to implement these prototypes. And then at the end, I'll make a proposal to the community that is based on the things that we are all building today. What are the things that we can do to help federation? So in the world today, what is emerging? So data and compute, right? You have some sort of data, you generate, you process it, you generate knowledge, make decisions, and then you do something more. So it goes with all kinds of applications. So here I show the mobile applications, but it's really not just the mobile applications, but all kinds of applications we use day to day. We see the infrastructure starting to change to leverage the fact that you can control these very complex systems with software. Because of the software, you can deal with high complexity, and because of software, you can automate these things. And what is changing from the past, we have a lot of these complex software systems, but what is different today is these software systems are becoming more and more open. So they focus on what is the interface that you want to build such that other entities can interact with your system. Connected vehicle is one research we do a lot at Clemson and also with a lot of our partners. That is one example of the kind of capabilities you want that is everywhere. Vehicles go everywhere, and vehicles are constantly on the move. So as they go through, they inevitably have to go through different domains of networking, different domains of computing, if they want to integrate any kind of application. And finally, big data. So within science, it's understandable all these different disciplines are generating data, analyzing that as the new trends of research. Right? We identify what are the new problems we can find from these data. But in reality, also, within all the different sectors of industry, big data is becoming a fundamental building blocks. So you try to analyze your problem, you try to support the different applications with the assumption that there's going to be a lot of data that you have to manage, you have to generate, you have to transfer. So that brings up three key common questions I see. First, the quality of service assurance. That going from the past to today, we have always been supporting with the network all these different applications. What is different today is the range of application that has to be supported on the network is so diverse, so wide, and then we are pushing the envelope of what we can support. So, for example, one of the latest NSF project we work on to build a new cloud testbed. The very first requirement is it has to support real time. So real time is very hard to do across the internet today. And how can we do going beyond supporting applications over internet into distributed infrastructure and still support that kind of guarantee? Ubiquitous. So you have to access your application between two ends of any applications. You have to go through diverse networks, diverse compute infrastructure. And then how do you interact with them? And how do you make them non-stop persistent? Like the vehicle case, you're going through all these different places. How do you connect into new networks, and how do you maintain your application continuously working over these different networks? And you may say that today we have that. If you sign up with a cellular provider, you can already be running your mobile apps anywhere you go. And that's going through the roaming agreements with different network providers. That's the case, indeed. But it's not going to scale if everyone is trying to run every app with that assumption. It's a very complex problem, and how do we make it easier, manageable? And finally, is the aspect of applications. So the applications are at the same time getting more and more. It's very diverse. Everyone expects some programmable aspect of your application, so you have different requirements. But at the same time, if you look into that, they all share very common requirements. So they have common framework with very different range of expectations within that framework. And that gives an opportunity for us to use software to solve the problem. We can identify and establish this common framework underlying such that people can be programming within that framework. So that's how I see that going forward. So with software-defined infrastructure, it's going to be on demand, it's going to be virtualized, which in some sense it's shared. And shared, you have different levels of expectation, what to share. So it's for the computing, you think about all the different data centers, and actually now more and more people think about it as a cloud. So cloud means you have compute utilities you can get to over network. In the past, you don't really care where the cloud is because it's in the cloud. So it's a resource you can get to, but you don't care where it is. Going forward, you will get a lot more of these infrastructures, but you may care where they are. But the nice thing that it will stay within a cloud context is the amount of resources that's going to be available in the cloud framework is going to be so abundant that you don't really care exactly where they are, but as long as you have the guarantees that you can access it within your certain constraints. So for network, similarly, you have a lot of these new type of software-defined network that is coming up. This is one of the Stanford lab view. They're showing all these different networks starting up. You're going to start to do things locally, and then gradually you are going to link them up together. And then within this framework, you can do a lot of things. Applications. So you have all these different types of application. The shared requirement is going to be large scale. Any application you introduce the very first day, you expect it's going to run in large geographic areas at large scale. So then within that, how do you manage them? Right? How do you scale? How do you handle all the complex requirements? And that goes into a software engineering problem. What is the way to support large amount of people, but all can have the confidence that they are receiving the same guarantees? So this last aspect answers that question, the on-demand virtualized services. So with today's technology, we can easily stand up new virtual machines. We can easily run a new piece of software. With software-defined network, we can insert software anywhere in the network data path. So with all these control elements, we can actually automate a lot of the requirements for the users without the users or the application even having to be aware of how they're starting. I may start up a new app. Automatically, the network providers will generate 10 different network software services on the network for me, such that I can run my app. So that's the kind of feature. So thinking about what kind of infrastructure we have, they can be, in the old sense, terminology, public cloud, private cloud, dealing with different type of users. And then more and more people are thinking about private, heterogeneous public and private cloud facility built together. The provider types, so operator, enterprise, these are very typical. More and more, I'm looking at commerce, like Starbucks. You can go to Starbucks, you can go to a coffee shop, expect free Wi-Fi today. Why can't you expect free compute tomorrow? Why can't you expect that you go to any location, you can connect to the network with the expectation that you can connect to your backend applications with very sophisticated services. We have the software available today to do that. The question is on the policy. How can these different providers allow you to do that? In the past, coffee shops ask you to ask for a password from the clerk. Put in a password, you connect to Wi-Fi. Today, everything is automated. You connect, you're connected. The assumption is you can connect to do simple things and you won't do bad things. And you can limit how they can do on the network. Why can't you do the same thing for computing? They can run any applications with the resources provided by the coffee shop. And because the software, the infrastructure is so software defined, you can start up these monitoring services, these control services to limit it. You don't have to bother the end user with that details, but you can automate the whole process. And household, you can run many resources easily yourself at home. So federation of the infrastructure is a must. It's a must so that you can support the scale, the ubiquity, the high availability that you expect for any application. And software defined is a must for solving the same set of problems. So this is how I see in the future the internet may look like. You have many different type of network providers at the bottom. They all connect to the backbone, again, many backbone operators. And if you see, there's so many data centers that's connected to these different networks. You can even have this tiny, small data centers that's connected to your home. So think about data center now as a logical sense. They all share the same software interface, but it doesn't have to all be the same Apple or Microsoft scale in terms of data center, right? The expectation is these are compute, and they can be everywhere, and you can talk, you can query, and you can run your applications. So going forward, the interesting thing will be, how do these different players, different users, different operators within the system interact with each other? What is their relationship? What kind of policy they care about? What kind of application you can run on them? So there's 4 game changers that I see that is making it very special today. So the compute is opening up, the network is opening up, the framework for applications, they're getting more and more consolidated and then similar. And the most important thing is the business models are opening up. The industry is starting to understand how to, based on open technology, open framework, without limiting your customers, you actually encourage your customers to come to your service while you provide your service by doing it on the back end. You can start up, enforce your policies in the back end, and you try to encourage people to come and leverage your resources so that you can have the creativity. So this is actually from the Berkeley lab in 2010. They analyzed cloud computing. At that time, they tried to find out what is the challenge and then what is the solution. So the same set of arguments still works today in this work, in the problem we're dealing with, but in a different context. Right? So I won't go through every single details of it, but you can see for all these different problems, it actually have a solution today because of the opening up of the compute and network that is software defined. So the building blocks, what are they? So the network on the left side, you can see this is a typical software defined network view. On the right side is a cloud. It's an open stack architecture. So what you see is a bunch of software stacks. You can interact with any aspect, any different levels at different interfaces. So NSI, Joe had just talked about it. It's how you can program the wider area network based on optical circuits. Internet 2, which is a US research backbone, is dealing with coming off this AL2 as advanced layer 2 service. It's also a set of API where campuses, universities are using that, starting to use that, and then love it to provision point-to-point connections among campuses. So Genie is another example of a framework, again, a set of API, how you can describe the resource and program them. So what is the most important thing is, what is using these frameworks, what are the people and the people's needs, the institution needs, and then what is the policy. So we started to have several NSF projects actually work with university partners to go one by one, go through integrating with your network, running shared applications on both campuses to try to find out all the things that we can do today manually and try to make it software defined tomorrow. So we go through several experiments. With ON Lab, we do the SDN and IP interfacing earlier, Internet 2 doing something similar. And then within my students, we look at the agent solutions using software-defined network, and we deal with it at different aspects of network. From the mobile devices to the edge networks to the core, we believe that we can all use the same agent architecture and interact with the SDN going forward. So the last project we have is Cloud Lab, which is a new distributed cloud infrastructure that allow people to study what is the future cloud architecture. So you can do any kind of experiments using these generic infrastructure across 3 different universities with the 100 gig backbone running, connecting them. So I won't go into details of these individual ones. It's really the several different project prototypes. What is interesting is this last slide. So that is, now that I believe the technical components are the simple things to solve today. We all know how to program them. And we all know that these are things that we can change in a very fast pace. What is fundamental and what is really the tough challenge is to start to work with different organizations. To start with simple case studies, understand each other's language, understand each other's university policies, organization policies, and work out simple exercises connecting different resources. That is how we are going to identify all these different requirements. And then we can put into the framework we have, or we can change the framework to fit those needs. So this is the very last slide I showed. This basically shows all the different research emphasis we have back from Clemson universities and how over time it actually connects well through Genie to the different industrial partners that we have and to the national communities we have. So I hope that that picture will also involve our international partnerships and work with people in this room. Thank you very much.
Question. Thank you very much. So if you think that new network must be ubiquity, you must do some standards and specifications. Does such area exist where you may do these specifications?
So what are the ways to do the specifications?
No, like HC in
So one thing that we do with, for example, for supercomputing last year, we worked with, from Clemson, California, USC, University of Southern California. We do a demo that goes from Clemson campus through Internet to going through the regionals and get to USC. So through this type of exercise, what we find out is different parts of the network have different expectations. You need to have different range of specification decided. So through that process, we find out the framework allows us to specify different specification, different scope, or different granularity for different parts, as long as you can understand what are those. So the software framework can actually be very extensible and adjustable. And we actually had a proposal working with Genie to try to get the Genie implementers to work with individual campuses to look at their current software infrastructure, how do they manage their local network connectivity, their local compute, to identify the specifications. And then we will come up with the same interface, but you can have that different range of specification. Is that what you're asking? Or we can probably talk more later on as well.
Some more question? Well, thank you very much. Oh, sorry.
Just quickly, given this whole software-defined evolution, how do you foresee our staffing requirements as we go forward? Where is this going? Are network engineers fossilized, or what do we need to move forward on that point?
So working with Clemson, our network engineers start with the original reaction is, this is just way over. This is not what production network should deal with. The kind of uncertainties, the kind of complexities. The solution we did is make out practical roadmaps, how we can manage the uncertainty. So that we, as a researcher, we try to set ways that we can control the uncertainty, convince the network engineer that this will work in a risk-free way. And as long as they have the time to be exposed to these elements, they start to gain confidence. They can manage that. They can actually go in and change things. So after 3 years, these network engineers change their mindset. They are willing to take a driving role on saying what kind of expectation they have on the network, talk to the SDN vendor on what is the expectations, and ask them to provide them. Right? So as long as we find a way, they can actually be transitioned to deal with the new type of infrastructure, rather than the earlier concern that they're fossilized, they can't do this, and they have to find a new job or anything like that. It's actually not. Network engineers, to some extent, is the geekiest community I know of, that they actually feel proud that they can solve these different challenges. As long as you give a way that they don't lose their job, they still run a good network, but at the same time they can involve new components.
Okay, thank you.
Sorry, can I ask? My last. Yeah. I have a little question. You talk a lot about SDX, SDI, and the main purpose of it is to perform interface for experimenters. You illustrate a lot of research areas, and my question is real using and real realization of cross-area experiments with, for example, biomedical and energy or some real implementations based on your SDX realization. Thank you.
So right now we have several different project areas, from wireless network to big data transfer over the network. So for example, for the genomics researcher, we actually collaborate, build a SDNA that helped them send the genomics data from NIH, from the National Institute of Health, download the data to our campus. And now we have a new NSF project that is sending data across 3 campuses. We identify a new gateway solution, which we call the genomics gateway, similar to the way that Joe positioned that, but at campus edge. So we start to have these prototypes to actually deal with real users, and then work with the production, work their IT, install that as a production service. So there are these use cases that servicing and getting more mature.
Thank you very much.